Hello everybody. In this universe, we have seen a lot of changes that take place. Even the formation of day and night, or revolution of the earth, the change of seasons. Now let us come to our kitchen. Even here we can see the curdling of the milk, the fermentation of the grapes, the souring of the fruits, or the fruits getting spoiled. Now what is happening here? Everywhere we see a lot of changes. Now this change can be of two types. Now whenever we have a change, they can be classified under two types. It could be only a physical change or a chemical change. Now let us consider the physical change. Here, as you have already studied in your lower classes, let us take a rubber band, the stretching of a rubber band. Initially, temporarily the rubber band is stretched, and again when we release it, it comes back to its own position. So what do we observe here? There is no permanent change that is taking place, and this change is reversible. So here we have only a physical change. The change that takes place is only for a temporary period of time. Now coming to the next type of change, where chemical changes takes place. Now in this regard, we have the curdling of the milk. If milk is kept outside during summer season, after some time you can see that the milk gets curdled. So here the example was the stretching of rubber band. And here the curdling of milk. To list a few more examples to this, even a cloth that is ironed, a crumpled cloth can be ironed and then again it can be crumpled back. So these changes are physical changes. And here to give another example, the fermentation of grapes. So that refers to chemical change. Now, today in this class, let us learn about such changes that take place. The change that takes place with respect to chemical aspect is called as chemical changes. So, in our day-to-day life, we have seen various happenings that take place. So, these happenings could be a physical change or a chemical change. So, let us study more about this in chapter 1. Here we will be dealing with chemical reactions and equations. Just now I mentioned a few examples of changes like the curdling of the milk, fermentation of grapes, and food becoming soft after cooking, and so on and so forth. In each of these examples, what you can see is initially you will have some substance. They undergo a change and then they give rise to some other substance. So the substance that we have initially changes and gives rise to some other substance. Here there is a lot of difference between the substance that is there initially and the substance or that is obtained later on. So these substances which react, these are called as the reactants, and after the chemical reaction that takes place, what we get is called as the product. So in chemistry, these reactions that take place are called as chemical reactions. Now look at the slide, observe carefully. Here is an activity where we take a clean magnesium ribbon of about 2 centimeters is taken, and then it is rubbed with sandpaper to remove the magnesium oxide that is formed on the top layer. Now, this is held with the pair of tongs and then it is burnt using a spirit lamp. After burning, the magnesium ribbon that was purplish grey in color turned into ash. Now, observe carefully the slide. You can see that when the magnesium ribbon is burnt, it gives rise to a dazzling white flame. So, initially the reactant, the magnesium ribbon, which was purplish grey in color, changed into some other substance, that is white ash. Now, let us take another example. Here we take a few granules of zinc and put it in a conical flask. Again, you can look at the slide here. You add little dilute hydrochloric acid slowly into the conical flask and shake it vigorously. Now, you can see very clearly some sort of effervescence that is coming out. These bubbles are giving rise, so you can see the hydrogen gas that is evolved or liberated during this reaction. There is also an indication of rise in the temperature in the conical flasks. So, when there is any change in any reaction, what could the change be with respect to? Now, let us see what the change is. So, when the chemical reaction takes place, the changes that takes place, it could be with respect to, number one, when we took the magnesium ribbon, it was with respect to their state. Initially, it was solid and ribbon in color. Later on, the product that we found was in the form of ash. Next, there was also a change in the color. The color, which was purplish grey in color, turned into white ash. Now, considering the second example, there what did we see? We saw evolution of gas. There was some sort of evolution of gas, also with an indication of rise in temperature. Rise in temperature. So, from this we can say that whenever a chemical reaction takes place, the changes that takes place could be with respect to their state, color, evolution of some gas, and also rise in the temperature. Now, this description of a chemical reaction, now if I have to describe this chemical reaction, it would be too long if I use a sentence, and hence it can be written in the shorter form. Now, the simplest way to write this chemical reaction that has taken place is by writing it in the form of a word equation. Now, what is this word equation? All of you in your lower classes have studied the different symbols for the elements that are present. Now, every element has got its own symbol which signifies the name of the element. So, this can be written in the shorter form. Now, let us consider the first experiment that we saw. The magnesium ribbon, here we will have to write as magnesium plus oxygen, which gives rise to magnesium oxide. Now, again, as I told you, it is difficult to write in the word form. This is the word equation. We can make it still simpler and write it in the form of their symbols. So, magnesium will be written as Mg plus O, which give rise to MgO. So, this way of writing the chemical formulas is called as chemical equation. Now, here you can see the new substance that is formed is magnesium oxide, which is formed after the reaction. So, these here are called as the reactants, and the final product that we get after the reaction takes place is called as the product. So, reactants give rise after a chemical reaction to some other product. Now, the reactants are always written on the left hand side, and in between the two reactants you can see a plus sign is used, and then on the left hand side we have between them a plus sign, and on the right hand side the product is written. If there are more than two products, we can also use a plus sign here to indicate. Now, what does this arrow indicate? The arrow ahead points towards the product and shows the direction of the reaction. So, here we have magnesium and oxygen giving rise to magnesium oxide. Now, let us see how to write the chemical formula for this. Now, we have written this as Mg plus O giving rise to MgO. Now, Mg but we know the formula for oxygen is O2. Now, count and compare the atoms of each element in the left hand side and the right hand side. In your lower classes, you have studied about the law of conservation of mass. Now, what does this state? The law of conservation of mass states that mass can be neither created nor be destroyed in a chemical reaction, but it can only be converted from one form to other. So, the total mass of the products that are obtained, of the products that are seen in the reactants, must be equal to the total mass of the products. Here, the number of atoms of each element remains the same before and after the chemical reaction. Now, let us consider this equation. Is this chemical equation balanced? No. So, how do we balance this equation? Now, let us learn to balance a chemical equation step by step. So, balancing a chemical equation. Balancing a chemical equation. The word equation for an activity that we did was zinc plus sulfuric acid gave rise to zinc sulfate plus hydrogen. Now, the above word equation can also be represented using their formulas. That can be written as zinc plus sulfuric acid is H2SO4 will give rise to zinc sulfate, that is ZnSO4 plus H2, which is a gas. Now, let us examine the number of atoms that are present here. Now, all of you observe the slide that is there on the left side. You can very clearly see that the number of atoms in the zinc and then hydrogen, sulfur and oxygen. Let us observe the number of atoms in the reactants. Reactants is the left hand side, and then the products that we get are on the right hand side. Now, in zinc on the left hand side, what is the number of atoms in the reactants? Zinc has got 1. Now, number of atoms that are present on this is the number that is present on the LHS, and then this is the number of atoms that are present on the RHS. On the right hand side, we have again number of atoms in the zinc as 1. Number of hydrogen atoms present here is 2. Number of hydrogen atoms present in the RHS is again 2. Now coming to sulfur, the number of atoms present in sulfur is 1 on the LHS, and the number of atoms present on the RHS is again for sulfur is 1. Coming to the last, oxygen, you have 4 atoms of oxygen and you have 4 atoms of oxygen again on the right hand side. Now, as the number of atoms of each element is same on both the sides, since they are same on both the sides, hence we can say that this is a balanced equation. Okay, now let us balance another equation. Here we consider iron, that is Fe plus H2O. So, which gives rise to Fe3 Fe3O4 plus H2. Now, again let us try to balance this by writing their numbers. Again we draw boxes here. So, we have iron, hydrogen and oxygen. So, again on the LHS and RHS, the number of atoms that are present. So, here we have 1 and here we have 3. In hydrogen, here we have 2 and here we have 2. In oxygen, we have 1 here and we have 4 here. So, now you can see that there is a difference in the number of atoms that are present. So, how do we balance this? First, step 1, to balance the chemical equation, draw the boxes. Do not change anything inside the boxes while balancing the equation. List the number of atoms of different elements present in the unbalanced equation like this. Now, coming to step 3, it is often convenient to start balancing with the compound that contains the maximum number of atoms. It could be either in the reactant or in the product. Now, select the element which has maximum number of atoms. As you can very clearly see that we can select Fe3O4 because it has more number of atoms when compared to others. There are 4 oxygen atoms in the right hand side and only 1 here on the left hand side. Now, balance the oxygen atoms. Now, how do we balance this? You can see in the slide, initially you have 1 in H2O and in the products you have 4 in Fe3O4. In order to balance this, you have to multiply this by 4. So, 1 into 4 and 4. So, here there is a balance. To equalize the numbers, it must be remembered that never alter the formula of the compounds or elements involved in the reaction. Now, for example, to balance oxygen atoms, we can put coefficient 4 in H2O. So, how can we can add a 4 here. So, this will balance the number of oxygens. Now, partly the equation becomes balanced, but again Fe and H are still not balanced. You can see that Fe and H are still not balanced here because 4 into 2 became 8. So, to equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the right hand side. So, that will become 8, and hence in the reactants it is 4 2s are 8 H2O. So, the equation would be now written as Fe 4 H2O giving rise to Fe3O4 and 4H2 in order to balance this and this. Now, step 5, examine the above reaction carefully and pick up the third element which is not balanced. Now, amongst them which is not balanced? Iron. There is 1 here on the left hand side and 3 here on the right hand side. Again multiply this by 3. So, this will become 3Fe plus 4H2O giving rise to Fe3O4 plus 4H2O. So, to equalize Fe we have added this. Finally, check if it is balanced. So, the number of atoms on both the sides should be same. Then we say that the equation is balanced. Let us check again. So, here we have 3 iron. We will try to rewrite after the balancing of the equation. After following these steps, we are rechecking. On the left hand side we have 3 Fe, on the right hand side we have 3 Fe. On the left hand side we have 4H, 4 and 2, that is 4 2s are 8 atoms of hydrogen, and on the right hand side we have 8 atoms of hydrogen. Oxygen is 4O and here we have 4 oxygen, and hence now you can see that the equation is balanced. So, compared to the earlier equation, now the equation that we have is the balanced equation. So, this is a balanced equation. Now, this method of balancing equation by putting numbers on the left hand side, on the right hand side and trying to balance them is called as the hit and trial method. Hit and trial method of balancing the equation. So, this method of balancing equation is hit and trial method, as we take many trials to balance the equation using the smallest number of coefficient. Now, the last step is writing symbols of physical states carefully. Now, we have various reactions. We also have to write which state it belongs to. While the reaction is taking place, it could be in the solid state, the liquid state, the gaseous state or the aqueous state. Now, considering the same example, we have 3 Fe and plus, first we will write the equation, 4H2O giving rise to Fe3O4 F4H2. Now, what is the state must also be observed. Here iron is in the solid form and hence it is written with a small s within bracket. Now, coming to water, generally water is in the liquid form, but here this reaction it takes part in the gaseous state and hence it is written as small g. Now, what happens to the product? The product, this what we obtain, Fe3O4 is in the solid state and again the H2 is in the gaseous state, and this is how we have the states of the following reactants and the products that we obtain. Now, here we have represented them depending upon their states. So, let us again try to correlate all of them. So, generally when we represent the gaseous state, when it is in the gaseous form, it is represented by small g. Sometimes it can also be represented by an arrow but facing upwards. Next, the liquid state is represented by L. Now, coming to the aqueous state. Now, what is aqueous state? When it is in the form of a solution, when it is mixed with water, then we call it as aqueous, which is represented by small letter A and Q. Now, coming to the solid state, they are represented by S. If the substance is solid, it is represented by Yes. Now, the physical states are not included in a chemical equation unless it is necessary to specify them. The reaction conditions also can be specified, like temperature, pressure, catalyst, etc. for any reaction, or this can be used by writing on top of the arrow. When the arrow is indicated, if we are using a catalyst, a small triangle can also be used to indicate that it is being heated, or we can also say that some amount of temperature is given by using the word temperature, or if some pressure is used, we can indicate it by writing 340 atmospheres, which indicates 340 atmospheric pressure. Suppose it is photosynthesis reaction, then the condition is sunlight. So, we can indicate by writing that sunlight, and what else is utilized? The chlorophyll. And hence, these are the different ways of representing the chemical reactions. Now, during a chemical reaction, neither the atoms of one element change into those of another element, nor do the atoms disappear from the mixture or appear from anywhere. So, whenever we are representing an equation, we have to show the reactants on the left hand side and the product on the right hand side, and indicate very carefully and check if they are balanced. Number 1, the number of atoms present on the left hand side, that is the reactants, must be equal to the number of atoms that are present on the right hand side, that is the product. And then the indication wherever is required, when certain at particular pressure, temperature variations are shown, that should be signified, and also the state if there is a change. Now, you may ask a question here, for example, water. Water is generally liquid. So, here because we have taken the gaseous form of water, which is the gaseous form of water? Steam. So, indicate that, that is why we have indicated it by writing G in between them. So, now having known how to write a chemical reaction, let us learn some types of chemical reactions. So, types of chemical reactions. During a chemical reactions, neither the atoms of one element change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Chemical reactions involve the breaking and making of bonds between atoms to produce new substances. Now, consider this example. All of you observe this slide. Here you can see the formation of slaked lime by the reaction of calcium oxide with water. Here calcium oxide is taken in a small beaker and slowly water is added to this. You can see the rise in the temperature. The calcium oxide here reacts vigorously with water to produce slaked lime, that is calcium hydroxide, also giving out a large amount of heat. In this reaction, calcium oxide and water combine to form a single product, that is calcium hydroxide. Now, formation of a single product from two or more reactants is known as combination reaction. So, the first one is combination reaction. Here solution of slaked lime, that is calcium hydroxide, which is solution of slaked lime, in which state, because it is solution, it is in the aqueous state, plus slowly what did we do? We added some carbon dioxide to it. The carbon dioxide gas, this gave rise to calcium carbonate. Now, calcium carbonate is again in the solid state, plus in the product we also have some amount of water. Now, water is liquid here. So, calcium hydroxide, what is this? This is calcium hydroxide in the aqueous state plus carbon dioxide gas gave rise to calcium carbonate and water. So, this is calcium carbonate. Now, here this type of reaction where two things combine to give rise to another product is called as a combination reaction. Some of the other examples is burning of coal. Now, coal is solid, this burns in air, air has oxygen. Now, again oxygen in the gaseous form gives rise to carbon dioxide gas. So, these two are examples for combination reaction. Now, coming to another example, formation of water from hydrogen gas. H2, that is hydrogen gas plus oxygen gives rise to water. So, when two or more substances, it could be in the form of elements or compounds, combine together to give rise to a single product, then the reaction is called as combination reactions. Now, here this reaction in activity 1.4 we also observed that a large amount of heat was evolved. Reactions in which heat is also released during the formation of product is called as exothermic chemical reactions. So, such reactions where a lot of amount of heat also is evolved is called as exothermic chemical reaction. That means it is liberating heat, exothermic chemical reaction. When two or more substances combine to form a single product, then we call them as combination reactions. So, this makes the reaction mixture. Some more examples of exothermic reactions are burning of natural gas CH4, which is in the gaseous form, burns with oxygen, which is again in the gaseous form. To balance this, we are writing another 2. This gives rise to carbon dioxide gas plus water. Again, to balance it, we write it as 2H2O, which is in the gaseous form, that is steam. So, this is another example for exothermic reaction. Now, is respiration an exothermic process? We need energy to stay alive. We get this energy from the food we eat. During digestion, the food is broken down into simpler substances. Rice, potatoes, bread, they all contain carbohydrates. Carbohydrates are broken down to form glucose. Glucose combines with oxygen in our cells of our body and provide a lot of energy to us. This special name for this reaction is nothing but our respiration. You can see how it helps in our respiration and also gives us energy. Now, coming to another example, the decomposition of vegetable matter in the compost pit is also an example of exothermic reactions. Now, coming to a decomposition type of reaction. you can look at this slide. The correct way of heating the boiling tube containing crystals of ferrous sulfate and of smelling the odor. Keep it tilted near the Bunsen burner and slowly bring it closer gently towards your nose. Taking about 2 grams of ferrous sulfate crystals in a dry boiling tube, you can see the color of ferrous sulfate crystals. Here, observe the crystals after heating it. The green color of ferrous sulfate crystals changed, giving a characteristic odor or smell of burning sulfur. Now, a single reactant can be broken down to give rise to simpler products. One big product giving rise to two types, this is called as decomposition reaction. Here, ferrous sulfate crystals lose the water when heated and the crystal's color hence changes. It then decomposes the ferric oxide to sulfur dioxide and sulfur trioxide. Ferric oxide is a solid while sulfur dioxide and sulfur trioxide are gases. Now, another example, that is decomposition of calcium carbonate to calcium oxide, and how carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide, the other name, is also called as quicklime. It has many uses in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. That is, decomposition reaction, when it is heated, it is called as thermal decomposition. Here is an example, you can look at the slide. Heating of lead nitrate gives out or emission of nitrogen dioxide. When limestone is heated, it gives rise to quicklime plus carbon dioxide gas. Another example of thermal decomposition reaction is, take about 2 grams of lead nitrate powder in boiling tube, hold the boiling tube with a pair of tongs and slowly heat it over the flame of the Bunsen burner. Now, what do you observe? You note the changes. We observe the emission of brown color fumes. Now, what are these brown color fumes? These fumes are the fumes of nitrogen oxide. The reaction that takes place here is lead nitrate when heated gives rise to lead oxide plus nitrogen dioxide with the release of oxygen. Now, let us consider the electrolysis of water. All of you have already studied this in your previous classes. Now, let us see which type of reaction it is. You know that we take two electrodes, the anode and the cathode, and water is heated. So, during this reaction, two holes at the base is fitted with rubber stoppers. Insert the carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill it with water such that the electrodes are immersed. Now, add a few drops of dilute sulfuric acid to the water. Now, take two test tubes filled with water and invert them over the two carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You can start observing that after some time bubbles are formed. Now, these bubbles are formed at both the electrodes. These bubbles displace water in the test tubes. Observe the volume of the gas collected in both the test tubes carefully. Once the test tubes are filled with respective gases, now remove them carefully. Test these gases. one by one. For the first one, bring a burning candle close to the mouth of the test tube. What happens in this case? Which gas does it represent? So, here one indicates the presence of hydrogen gas and the other burns with a slight flame which indicates the presence of oxygen gas. The one which gives the pop sound indicates the presence of hydrogen gas. Now, let us consider another activity. Take about 2 grams silver chloride in a china dish. Now, what is its color? Place this china dish in sunlight for some time. Observe that the color of the silver chloride after some time changes. The silver chloride now turns grey in the presence of sunlight and forms the silver metal. So, here white color silver chloride has turned into grey in the sunlight. Why does this happen? Again, this is due to the decomposition or reaction, that is decomposition of silver chloride into silver and chlorine in the presence of sunlight. Similarly, we also have silver bromide which also behaves in the same way. The above reactions are used in black and white photography for the photofilms. Now, what form of energy is causing these decomposition reactions? The decomposition reaction require energy either in the form of heat or in the form of light or electricity, breaking them down to form the various reactants. The reaction in which energy is absorbed, here you can see that the energy is absorbed and hence it is known as endothermic reactions. Now, coming to the next type of reaction, the third type, here we call this as the displacement reaction. Look at the slide here. We take 3 iron nails and clean them by rubbing them with sandpaper. Now, take 2 test tubes marked as A and B. In each test tube, take about 10 ml of copper sulphate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulphate solution. In the test tube B, for about 20 minutes later, you keep another nail aside for the comparison. After 20 minutes, take out the iron nails from the copper sulphate solution. Compare the intensity of the blue color of copper sulphate solution deposited in the test tubes. Also compare the color of the iron nails dipped in the copper sulphate solution with the one kept aside. Here, the iron nails dipped in the copper sulphate solution, you can see that there is a change in the color. The iron nail taken out from copper sulphate solution is brownish red in color. The test tube here, when the iron nail becomes brownish in color and the blue color of the copper solution fades, the following reaction is taking place. Copper sulphate iron is reacting with this aqueous copper sulphate solution to give rise to ferrous sulphate plus copper. Here, iron has displaced or removed another element, copper, from copper sulphate solution. This reaction is known as displacement reaction. Other examples of displacement reactions are zinc and lead are more reactive elements than copper. They displace copper from its compounds. Now, you can see this example, zinc which is in the solid state plus copper sulphate solution which is in the aqueous state. When they react, they give rise to zinc sulfate, which is in the aqueous state, plus the copper, which is in the solid state. Now, what is happening in this reaction? The zinc copper sulfate here is displaced. This displaces copper and keeps it aside, and the zinc reacts with sulfate. They both combine. The copper that was present with copper sulfate is displaced. It is removed from its place with sulfur sulfate, and then it is pushed aside. So, this displaces copper and combines with zinc and gives rise to zinc sulfate. This type of reaction is called as displacement reaction. Now, coming to the formation of barium sulfate and sodium chloride reactions, these also undergo displacement reaction. Now, let us consider the last type of chemical reaction, that is double displacement reaction. Here, a white substance which is insoluble in water is formed. The insoluble substance formed is known as precipitate. Any reaction that produces a precipitate can be called as precipitate reaction or precipitation reaction. Now, let us consider the example here. Here, we take sodium sulfate reacting. Now, this is in the aqueous state. This reacts with barium chloride, which is also in the aqueous state, and gives rise to barium sulfate plus sodium chloride. Barium sulfate is in the solid state and sodium chloride is in the aqueous state. Now, sodium sulfate plus barium chloride gives rise to barium sulfate plus sodium chloride. Now, you can see this reaction is the double displacement type of reaction, the fourth one. Now, what is it displacing? There is a double displacement here. What you can observe, sodium sulfate, here it displaces the sulfate, that is, it throws out the sulfate and combines with chlorine and gives rise to sodium chloride. Similarly, the barium chloride, it displaces chlorine, combines with sulfate and gives rise to barium sulfate. So, both of them are exchanging their combinations, displacing the elements, and hence we can see double displacement taking place here. So, such types of reaction are called as double displacement. Such reactions in which there is an exchange of ions between the reactants are called as double displacement reactions. Now, coming to the next type, that is oxidation and reduction. So, we have seen the four types of reactions. Now, let us see what we mean by oxidation. The name itself indicates that there must be oxygen present. Now, let us consider this example. Copper reacts with oxygen reacts with oxygen. When some amount of heat is given, it gives rise to copper oxide, cupric oxide. Now, let us balance this equation 2. So, here when we heat in a china dish about some copper powder, it gives rise to copper cupric oxide. The surface of copper powder becomes coated with black copper oxide. This is because the oxygen, when it is added to copper, it gives rise to copper oxide. Now, if hydrogen gas is passed over this heated material, now let us say we consider the black coating of copper oxide. Now, this copper oxide that we obtain, if some amount of hydrogen gas is passed over this heated material, the reverse reaction takes place. What happens is, this gives rise to copper plus water. You can see that we get back the copper. If a substance gains oxygen during a chemical reaction, the substance is gaining oxygen, then it is said to be oxidized. Now, what do you think happens when it loses oxygen? When the substance loses oxygen, then we say that it is reduced. During this reaction, the copper oxide is losing oxygen and is being reduced. Here it was gaining oxygen, and hence we call this as oxidation. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called as oxidation and reduction. So, whenever in a reaction one reactant gets oxidized while the other gets reduced, then we call such reactions as oxidation reduction reactions, or they are also called as redox reactions. Redox reactions. The other name of oxidation reaction is redox reaction. Some of the other examples are zinc plus, that is ZNO plus C carbon gives rise to, here first it undergoes oxidation reaction. So, Zn plus CO. Next again the same, we have MnO2 manganese oxide reacting with hydrochloric acid to give rise to manganese chloride plus water plus we have chlorine. So, here you can see the examples of, these are the two examples of redox type of reactions. Redox reactions. In this reaction, carbon is oxidized to carbon monoxide and zinc oxide is reduced to zinc. In the other reaction, we can see that hydrochloric acid is oxidized to chlorine, whereas manganese oxide is reduced to manganese chloride. If a substance loses oxygen or gains hydrogen, then during such a reaction we call that it is a reduced reaction. Okay, now let us consider another equation for balancing. Here we have iron plus H2O, which gives rise to Fe3O4 plus hydrogen. Now, before balancing, first we write the name of the elements on the left hand side, that is we have iron, hydrogen and oxygen. This is the left hand side, and here we have the number of elements in the products, that is the right hand side. So, how many number of atoms are there in the reactants? Considering iron, here we have 1, and here as you can see we have 3. In hydrogen we have 2, and here again we have 2. Now what about oxygen? Here we have only 1, and here we have 4. Now, in order to balance them, whether it is a reactant or a product, the first thing is select the element which has maximum number of atoms. Now, using this criteria, as you can see, we can select Fe3O4 because they have the maximum number of atoms. Here we have 4 oxygen atoms on the right hand side and only 1 on the left hand side. Now, how do we balance these oxygen atoms? Initially, to equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or the elements involved in the reaction. So, we need to add 4 here. So, multiply this by 4. So, what happens? We get 4 atoms of oxygen. Now, for example, now partly here by adding 4 the equation is balanced. Still there is something left out to be balanced. So, in the next step we have iron and hydrogen. They are still not balanced. So, picking any of these elements further, let us try to balance the number. To equalize the number of hydrogen atoms, make the molecules of hydrogen same on both the sides. Now, you can see we have 4 and 2, 4 2s are 8 here, and here we have only 2. So, how do we balance them? By adding 2 on this side, we can balance it and make it as 8. So, we write 4H2. So, now we have 8 here and 8 here, and hence now this is balanced. The hydrogen and the oxygen atoms are balanced now. Now, this equation again when we examine, we see that there we yet have to balance the number of atoms in the iron. To equalize iron, we take 3 elements of iron on the right hand side. So, here it has become from 1, it has become 3 now. So, now you can see that there is a balance on both the left hand side and the right hand side. So, all the atoms, iron has 3, 3, hydrogen 8 and 8, oxygen 4 and 4. Now, the equation that we have obtained here, after the step by step balancing, is a balanced equation, and hence finally we check the correctness of the balanced equation by counting the number of atoms of each of these elements. This equation is now called as a balanced equation. Since The method adopted to balance this is just done by taking trials one after the other. This method is called as hit and trial method. Hit trial method of balancing. So, we all know what is oxidation and reduction. In this class, let us see what are the effects of oxidation and reduction. So, the effects of oxidation and reduction. All of you must have observed iron particles initially when they are new are shiny, but slowly later on as days roll by they get coated with reddish brown powder. So, the reddish brown powder formed on them is because of the oxidation of iron. This process is commonly called as rusting of iron. Chemically, this is an oxidation reaction. Some other metals also get tarnished in the same manner. All of you must have observed silver also undergoes oxidation. Here it becomes blackish. There is this black coating on silver. This is also one of the effect of oxidation. Now, coming to copper, copper also undergoes oxidation, but here we can observe that the color is greenish. So, these are some of the effects of oxidation of metals in our day-to-day life. So, when a metal is attacked by a substance or when it undergoes oxidation, then it is set to corrode. What happens is the metal gets worn out, and you can see this wearing out is called as corrosion. So, then what is corrosion? The black coating or a metal getting attacked by substances around it, especially due to moisture or oxygen or acids etc., are set to corrode, and this process is known as corrosion. The black coating on silver and the green coating on copper are some of the examples of corrosion. Now, corrosion causes a lot of damage. You must have seen car bodies, the bridges, the iron railings, ships, and several objects made up of metals, especially that of iron, undergoes corrosion. Now, corrosion is a major problem. It is a very serious problem because it spoils the metal. Now, every year an enormous amount of money is spent to replace damaged iron. So, corrosion can be avoided by painting these metals. Now, coming to the next type, have you ever tasted oil substances which are a little old, or have you smelt fat or oil containing food materials which are left for a long time? These fats and oils also get oxidized. The fats and oils get oxidized. Now, they become what is called as rancid. And this process is called as rancidity. Usually, substances which prevent oxidation are added to foods containing fats and oils. How can this be avoided? Now, keeping food in airtight containers helps to slow down this oxidation. I am sure all of you are familiar and you love eating chips. The chips that come from flush bags. All of you can remember your Lay's chips packets, the Bingo, the other packets of chips that you eat. They all are puffed up. Now why are they puffed up? Why do they look like that? Unlike the olden days where you would get them in the normal plastic paper, here you can see that they have flush types of bags because there is some gas inside it. Now which is this gas? This is nitrogen. Now why is nitrogen flushed into this? The nitrogen is flushed into these bags to prevent the chips from getting oxidized and thus prevent the rancidity, and hence we can use these chips for a longer time because it prevents the oxidation. So these are the effects of oxidation and reduction.